I'm going to do number 4 and 5 at the same time because, they go together. Point of inflection and concave up or concave down interval. So let me see. I'm going to go ahead and copy this and put the work down here. What I need is, some of these numbers that we got already, we do need the original function and the first derivative. So I'll just copy this. I'll copy this down here. So if you want to find points of inflection, you have to set the second derivative equal to 0. So start with that. Start finding the first derivative, which is 3x squared plus 2x minus 1. Now take the derivative of that. F double prime is 6x plus 2. Set this equal to 0 to find the x coordinate of a potential point of inflection. Subtract 2 from both sides, you will get -2 equals 6x. Divide both sides by 6. We can reduce that fraction and get x equals -1/3. You're now going to sketch a number line. Let me move this work to the left here. I'm going to sketch a number line that has -1/3 in the middle. And we will check the sign of the second derivative to the left and to the right of this point. Okay? So let's pick a number that is smaller than -1/3. -1 is smaller than -1/3. So I will plug in -1 into the second derivative. So note that the second derivative is 6x plus 1, right? Now 6x plus 2. So if you plug in x equals -1, let's see what we get. That will be 6 times -1 plus 2. That is -6 plus 2. Well, look, that's negative number. So when that second derivative is negative, we're looking at an interval that is concave down. Okay, now let's pick a number that is to the right of -1/3. Pick a number that's bigger than 1/3, -1/3. 0 is bigger than -1/3. So I will plug in 0 into this second derivative. That will be 6 times 0 plus 2, and that is 2. And looking at positive second derivative, we know this interval that we picked this x equals 0 from must be concave up. So we're going to write down that this interval is concave down, or this graph is concave down on -∞ to -1/3 and concave up on -1/3 to infinity, and that we have a point of inflection at -1/3. And now we do not know the y value, so we will plug in -1/3 into the original function to find its y coordinate. So look, I'm going to plug in -1/3. -1/3 cubed plus -1/3 squared minus -1/3 plus 1. Convert this into a fraction. So the point of inflection happens at -1/3, 38/27. So I'll put that number 38/27. So let me go back and see if we answered both part of this question completely. Did we use the second derivative to find the coordinates of any points of inflection? Yes, we did, right? We found the point of inflection. Right in order pair. Yes, we wrote that in order pair right here. So number 4 is done. So we found the point of inflection. Number 5, did we identify intervals where the function is concave up or concave down? Yes, we did. And we definitely show second derivative signs for each interval. We did that right here. So the sign came out to be negative, so that's why we concluded this is concave down. When the second derivative had a positive sign, that's when we say this is concave up. So that concludes this big problem, but this is something that I definitely want to include on your chapter 3 test, okay? Where you use your second derivative test skill to answer it's like 5 different part problem. But that's it for section 3.2.